All right. Hello, everybody. So we are going we'll have kind of two videos for today. So this will be the first one. It's about another kind of formula. So the formulas that you wrote before, those were what we call explicit formulas. Mainly the thing with those formulas is that you can plug in the end value that you're looking for. So if you're looking for a specific term, you just plug in that term and you're good to go. Recursive formulas are useful when we're talking about some more complicated types of sequences, but they can be used also for arithmetic and geometric as well, all right? We're going to talk about these recursive formulas. They're not necessarily my favorite thing. I think the explicit ones are so much more useful, but they're pretty straightforward. So I think you'll be like, okay, wow, that's not too bad. All right, so we're going to go ahead and do this first one. It says write the explicit formula and then the recursive formula. And so that way you'll be able to see the difference between them. All right, so taking a look at this sequence, I can see that it adds 5 every time. So I am going to go ahead and write the explicit formula. So I'm going to label it so you know which one's which. And so our nth term, a sub n, will be based off of the first term. You have to tell, hey, where this sequence is starting. It's going to start at 33. We add 5 to every term. And when we look for the nth term, you plug in n minus 1 in there. So, like, for example, if you wanted the 20th term, you would plug in 20, and that would give you the 20th term. For the recursive formula, it's a little bit different. I spelled this wrong. Hold on. Recursive. And the recursive formula has essentially all the same information as this one, but it kind of comes in two parts. So the first thing, just like in the explicit, you have to say, hey, where does this start? You have to tell me what the first term is or what a term is. You have to tell me at least one of the terms in the formula, because without one of them, I have no basis of knowing where we're starting. So we would say a sub 1 equals 33. And then the second part of this formula is the formula for a sub n, the nth term. And so what's going to happen when you write this recursive formula is it's always based off of the term that comes before the nth term. So for example, if we're talking about the 20th term, we're going to base this equation off of the 19th term, the term that comes before it. And so how you denote the term that comes before it is a sub n, but minus 1. So if n was 20, n minus 1 is 19. And so that's the term that comes directly before this term. And then what are we doing between all of the terms? We're adding 5. So if you have the term that comes before, you find the next term by simply adding 5. And so this is actually, the recursive is actually a lot more useful when you're not talking about arithmetic and geometric type sequences. It's much more useful when we get into some more complicated ones, and we'll see some more complicated recursive formulas at the end of this lesson. But your explicit formula is really the most useful because you could find any term. So for example, if I was like, hey, I want the 30th term, if I want the 30th term, using the recursive formula is not very easy because to find the 30th, it would be based off the 29th, and the 29th would be based off the 28th. So it's not as useful as just saying, hey, I want the 30th, just plug in 30. All right, I'm going to leave the other 3 for you to try on your own. So we're going to jump down to number 5. We're going to see one in this section. So it says, once again, explicit and recursive formulas, but these ones are all geometric. So first of all, what is happening here? We are timesing by 3. Remember, for geometric, you always want to write what's being multiplied by. All right, so if we're timesing by 3, then for the explicit formula, this is the one where you can just plug in n and get any term. It would be the nth term is the first term times 3, and then that's to the power of n minus 1. So if you wanted the 30th term, you just plug in 30, and this would go ahead and you could just calculate it. Bam, there's your 30th term. For the recursive formula for this one, you still have to say a starting spot. So I'm going to say a sub 1 because we know that that's equal to 3. And then from there, you're going to say, okay, the nth term is based off of the term that comes before it, which would be n minus 1. And what do you do to the term that comes before it? Well, you would take the next term. To get the next one, you times by 3. To get the next one, you times by 3, times by 3. So this is times by 3. So once again, the recursive formula, if I wanted the 30th term, not as easy if I just have this, right? Because you can't just plug in 30 and get your number right away, where the explicit one you can. But the recursive formulas are more helpful the more complicated the sequences get, for sure. All right, so I'm going to leave the next 3 in this section for you to try on your own as well. All right, and then here is kind of the last example we'll do on this front side. It says, given the explicit formula for a sequence, write its recursive formula. So taking a look here, this is what kind of sequence? This is actually arithmetic, and it's written a little bit different. It has the times by 10 after the n minus 1 instead of before. But with multiplication, it doesn't matter the order that you write it in, right? So technically, instead of times by 10 at the end, you could times by 10 in the front, right? And so they try to be a little sneaky here by where they put the times by 10. But really, we're saying, okay, it's the first term, negative 31. We're going to add 10, and we're going to do it n minus 1 times, and that'll give us our nth term. So whether it's n minus 1 times 10 or 10 times n minus 1, it doesn't matter the order there. So you can always just move that over. All right, so for the recursive formula, you have to say, where are we starting? So what's the first term? Well, the first term is 31. And then for the nth term, we're going to pay attention to the term that comes before it, n minus 1. That's the term right before the nth term. And what are we doing with that term? Well, based off of our equation here, we're going to add 10 to that term every time. We just keep adding 10, adding 10, adding 10, and that's how we get our sequence. All right, same thing is true if you're looking at a geometric equation. We know this one's geometric. There's a multiplication factor going on here. So when you go to write the recursive formula, once again, you have to say, where does this start? You have to give us kind of like a point of reference. So it's going to start at negative 4. And then your nth term will be based off of a sub n minus 1. And what are we doing? We are timesing by negative 4 every single time. Or not negative 4, I'm sorry. What? Negative 6. Don't mind me. We're timesing by negative 6 every single time. And so if you don't like to write it like this, you could also write a sub n minus 1 and then parentheses negative 6. Or you can put the negative 6 in the front, which is typically how we do variables, right? And say negative 6 times a sub n minus 1. All 3 of these mean the exact same thing. All right, I'm going to leave the other 2 for you to try on your own. All right, so it says, given the recursive formula for this sequence, find the first 5 terms and then the 10th term. So the really nice thing is, hey, they go ahead and tell us the first term, right? So I'm going to make my sequence up here. So the first term is negative 3. In order to find the next term, you have to recognize what the pattern is. And this equation here, this first part, is going to tell you what the pattern is. To find the second term, you're going to use the term that comes before the first term and subtract 7. So specifically, here's what that looks like. A sub 2 is equal to a sub 2 minus 1, subtract 7. Well, a sub 2 minus 1, that is a sub 1 minus 7. So your second term is found by taking your first term and subtracting 7. So take this term, subtract 7, we get negative 10. If we wanted to find the third term, we could do the same thing. A sub 3 minus 1, and then subtract 7. And so that would be a sub 2 minus 7. So take the second term and subtract 7 for your third term. So take this one, subtract 7, we would get negative 17. And so you can kind of see the pattern here, right? You're going to find the next one by subtracting 7. So it'd be negative 24. Subtract 7 again, negative 31. And there is your first 5 terms. Now to find the 10th term, because it says, hey, all right, you found your first 5, now find the 10th. You have 2 options. You can either continue this pattern out until you get to the 10th one. You can subtract 7, subtract 7, subtract 7, subtract 7. Or if you wanted to find the 10th term, you could write the explicit formula. The one where it says, hey, put in the first term, and then tell what we're changing by. Well, we're subtracting 7, and then n minus 1, but specifically we want the 10th term. So you're writing your explicit formula, but specifically for 10. And then you can just throw this in your calculator and calculate it. So either way, if you want to find the 10th term, you can either keep going in your pattern, or you can write the explicit formula and then just use your calculator to do that. If this said like the 50th term instead of the 10th, I would not recommend writing them all out. Instead, I would recommend go ahead and writing the equation. All right, so let's see. This is 9, negative 63, so negative 66 for your 10th term. All right, I'm going to let you try those other 3 as well as practice. And then we will talk about this last section. So we have find the first 5 terms in each sequence. So this is actually written a little bit different. And this is one of those ones where this is not arithmetic, it's not geometric, it's a neither. But writing the recursive formula for this sequence is actually kind of the easiest way to write a formula for it. And so we're going to kind of go through each of these and figure out exactly what the sequence is, all right? First 5 terms. So the nice thing, hey, we got the first term. It's negative 8. For your second term, you're going to use your equation up here. You'll do a sub 2, second term is a sub n minus 1. Well, 2 minus 1 is 1, so your first term. And then you're going to add the n. Well, we're talking about the second term, so we're adding 2. So to find your second term, take your first term and add 2. So that would make it negative 6. To find the third term, a sub n minus 1, well, 3 minus 1 is 2. So take the second term and add n. Well, in this case, n is 3, not 2 anymore because we're not in the second term, we're now in the third term. So now it's take the second term and add 3. So this would be negative 3. A sub 4 is going to follow that same pattern. You're going to do the third term, 4 minus 1, third term. And in this case, we're going to add 4 to it because it's the fourth term. So take this number, add 4. And then the last term here, the fifth term, take your fourth term and add 5. So 6 plus 5, or 1 plus 5 is 6. And so here would be your sequence. It's add 2, add 3, add 4, add 5. So the next one would add 6, add 7, add 8. And so this isn't arithmetic. It's not geometric because it's not a constant being added / multiplied. And so this neither sequence was best described by using a recursive formula. All right, next one looks a little bit different. So we have our first term, it's negative 6. And then to find the second term, we're going to use this formula here. It'd be 2 plus a sub n minus 1. So if n is 2, we'll subtract 2 minus 1 is 1, so your first term, and then divide it by 2. So 2 minus 6 divided by 2. 2 minus 6 is negative 4. Negative 4 divided by 2 is negative 2. So your second number is negative 2. And then keep going. For your third term, it's going to be 2 plus, and then a sub 3 minus 1. So a sub 2 all over 2. So now we're going to use the second term. So 2 plus negative 2 all over 2. And so this is 0 over 2, which is equal to 0. So your next term is 0. A sub 4 is 2 plus a sub 3 all over 2. And so that would be 2 plus 0 over 2. So 2 over 2, which is 1. So your next number is 1. And you can probably start to recognize the pattern. This was an add 4, add 2, add 1. So if you recognize what's happening here, the next number should come from adding 0.5. If you don't recognize it, though, you can go ahead and just use your recursive formula to find a sub 5. You will get that it is 3 over 2, or 1.5. So in your homework from the first day of this trimester, the first day in class. This was one of the sequences that was in there. Let's see if I can find it. Where did it go? It's number 39. So 39 on your homework, this was the sequence. That's the same one that we have. And on your homework, you were asked to write the explicit formula and to try to write a formula if it wasn't arithmetic or geometric. So this one was really hard to write the formula, and it's actually best represented as a recursive formula. That gave us the exact same sequence. But once you recognize the pattern, right, you could go ahead and figure out a sub 10 by keep going. All right, let's take a look at the next one. So this one, they give us the first two terms, which is kind of different. So the first term is -6. The second number is -2. And so we're going to start by finding the third term. And so a sub 3 is equal to a sub 3 minus 1. So that's 2. So a sub 2 plus a sub 3 minus 2, and 3 minus 2 is 1. So a sub 1. So if you plug 3 into all of those ends and calculate it, it's saying the third term is equal to the second term plus the first term. So the reason they give us both terms is because to calculate the third, you actually have to have the first two. So we're going to go ahead and just add these together. -2 plus -6 gives us -8. The fourth term would be a sub 4 minus 1, so that's 3, plus 4 minus 2, that's 2. And we go ahead and add the third and the second term together now, so that would be -8 plus -2. And that gives us -10. And so this recursive formula, the next number is based off the 2 that came before it. So the 10th, or not the 10th, the fifth term would be -8 and -10 added together, so -18. And you could also do that by calculating a sub 5. That would be a sub 4 plus a sub 3, right, which would be -10 plus -8, which is -18. And so recursive formulas are the most useful when you kind of have this unique pattern going that can't really be defined in using equations, using explicit equations. Some of them can be defined with explicit equations, but they're a lot more complicated to try to write and figure out what's going on for sure. All right, I am going to leave number 20 for you to do on your own. So give number 20 a shot. And when you are done, when you have finished, hold on, I have lost the order here. There we go. Okay, time out. So going back to the front, when you finish these three, and then these two down here, and then finish on the back of these three and this one, then you can go ahead and submit this assignment on Google Classroom. Let me know as you're working if you have any questions. I am here to help, all right?